All right, number one. What is the physics definition for energy?
We just put something that enables an object to do work.
So I really like that he called it the something. Energy is made up. It's literally, someone was like, hey, why do things do stuff? And someone else was like, oh, they have energy. And somebody was like, what is energy? And he's like, don't worry about it. Okay? That's kind of what energy is. It's what objects have in order to do stuff. And the stuff is work. Remember, work is the ability to change an object's energy. So energy is needed to do work, but work is needed to change energy. It's a chicken-eggy thing.
And then for number 2, we said that mechanical energy is energy due to the position of something and the movement of something.
Good. So it's energy due to position, where you are, and movement, how fast you're going. Number 3, what is potential energy? Somebody.
Energy.
Stored.
Energy stored and held in readiness.
So readiness is a funky word. It just means energy you can use. Not the energy you're using now, but energy you can use. So it's stored energy, held in readiness. You can use it. You're just not using it yet. All right, and examples the book gives. So a spring, stretched or compressed spring, a stretched out rubber band. Anything that can use energy but isn't using energy yet. So if you compress a spring, when you let go of it, it's going to boing, right? That's stored energy. When you have a rubber band and you stretch it out, if you let go, it'll go flying or it'll smack someone on the leg or whatever you're doing. Good? And number 4, what's gravitational potential energy?
Potential energy due to elevated positions.
Good. The equation is weight times height. I'm going to add to the equation. So the way we're going to write it is PE equals mgh. That is the exact same thing. Remember, mg is weight. And the height above what? The height is above some reference level, or I'm going to call it 0. Whatever you're deciding 0 is. Usually that's the ground, but it's not always the ground. Okay, I got a hand sanitizer bottle on the table. Yes, I could say it's the height above the ground, but it probably makes more sense to say the height above the table since it's sitting on the table not doing anything. Okay? That would make more sense, and that would make the problem easier. Okay? That would have a height of 0, and it would give me a potential energy of 0, which makes sense. It doesn't really have energy. It's not really going to do anything. It could, I suppose, if I bumped it, but it's probably not going to do anything on its own. Whereas it makes sense to make the ground 0 for an apple hanging in a tree because the apple could fall at some point. You just don't know when. Okay? Any questions on 3 or 4? All right. Okay, number 5. What does gravitational potential energy in an object always equal? It always equals the work done to get it there. Okay? Work is force times distance. If I'm lifting an object, it's work against gravity, mg, times the distance, which is the height, gives me mgh. The equation for potential energy we just wrote down was mgh. So in other words, the work is force times height, force times distance, and that is mgh. Number 6. So the figure on 7.6, page 114, shows the gravitational potential energy of a boulder 3 meters above the ground is the same no matter how the boulder got there. Explain why that's true.
Each would travel 3 meters to the same height. And that's pretty much why they have the same potential.
Yeah, they both go 3, or all 3 of them go 3 meters, and they end up at the same position. So it doesn't matter how you get there. It matters what's your weight, which won't change, and what's the height. Well, if the height is the same for all 3, then the potential energy is the same for all 3. So it doesn't matter how you get to a place. Okay? If I wanted to get on a desk, if I step on it, walk up a ramp, walk up a step stool, jump onto it, it doesn't matter how I get up there. It's the same potential energy when I get there. So how you get somewhere doesn't matter. All right, and number 7. Would an apple held 1 meter above the ground on Earth and the moon have different gravitational potential energy values, and why?
Yeah, they would have different potential energy values because the gravity is different, so the weight would change.
Good. Weight times height. If your weight is different, you're going to have different potential energies. So how do you have 2 different potential energies at the same time? By having 2 different 0 points. So that book on the desk kind of example, or the hand sanitizer example I gave, you can say the ground is 0, in which case you have weight times height above the ground. Or you can say the table is 0, in which case your potential energy is 0. What is kinetic energy?
Kinetic energy is the energy of motion.
Good. And it's 1/2 times mass times velocity squared. 1/2 mv squared.
Or speed.
Yep, or speed. Either way. Yep. I like you being thorough all on, right?
Oh, do I? Okay. So, what is relationship to kinetic energy? So basically, work equals the change in kinetic energy. When an object is moving or in motion, it's capable of doing work, and during this motion, the object gains kinetic energy from the work being done.
Yep. This is the main point. Work equals a change in kinetic energy. So, if you do work, you will change its kinetic energy unless you're doing work to give potential energy. Okay? If you're doing work to give it potential energy, then that's all you're doing. You're just giving it potential energy. But if you're talking about motion of objects, if you're talking about the motion of objects, then you're talking about changing kinetic energy. Excellent. All right, last 2. 11 and 12. So number 11, why is a car traveling twice as fast as another? Why will it take 4 times further to stop when applying the brakes? So I set up 2 equations, W equals delta KE. Delta means final minus initial, so final minus initial kinetic energy. It says it stops, so the final kinetic energy is 0. Minus the initial. Initial is 1/2 mv squared. So it becomes work equals 0 minus 1/2 mv squared. So just work equals negative 1/2 mv squared. And then I wrote in the work equation, which is FD. And I want you to see these two things I circled, distance and velocity squared. So the mass won't change. The force won't change. The two things that will change are the distance and the velocity. So why is the distance 4 times further? Because v is squared. Last thing that you need to know. What values do kinetic and potential energy go with? Kinetic goes with velocity, potential goes with height. The mass will usually not change, so we don't worry about mass too much. You need to know what it is when you're solving, but mass is not a big, super important thing. The kinetic energy goes with the velocity, so 1/2 mv squared. And the potential energy goes with height. Weight, so that's mg times height. So, I'm very rarely going to give you a problem where I say find the potential energy. I will sometimes here early on while we're just getting used to it and figuring it out. But usually I'm going to be asking you to find the height or asking you to find the velocity. Or doing something like was in 11, finding the distance traveled or the force applied or something like that. That's usually what you're going to end up with.